Good afternoon to all, and thank you, Frank, for the invite. I am glad to, interact with all of you through the course of the next 45 minutes through this talk. I am Shankar. So I work in the Department of Engineering Design at IIT Madras. And I am going to talk about safety and e-mobility of heavy road vehicles. Before I go into my talk, let me acknowledge my students whose research is something which helps me to learn every day. And most of the material that I'm going to share with you in today's talk has been learned along with them, over the course of the past few years. So before I go to the technical part of the talk, I thought I will show you where I am from. So I am from Chennai. So you can see it there. So that is on the south, the southern coastal region of India. So, and it's in so you can we can get a relative position of where we are. And IIT Madras is the premier institute, if not one of the most premier institutes in India. And that's a snapshot of the institute. Chennai is a metropolitan city in India, and IIT Madras is in the forest area. So the joke goes like, we are living inside a forest in the heart of the city. You can see a green area in between, but then surrounded by huge, multi-story buildings, right? So, and there's metropolis around it, right? So, sort of like I am very fortunate to be in this green campus. So it's a reasonably large campus of 250 acres. We have 16 academic departments and around 20 odd faculty members and around 10,000 plus students, including research. And we also have India's university-run research park, IITM research park, which also I believe one of the largest in Asia. So we interact a lot with industries through this IITM research park. And about my department, it's the Department of Engineering Design. So that is the building. So the overall object of this department is to develop well-trained design professionals. We have an interdisciplinary curriculum, with our curriculum having courses from mechanical sciences, electrical sciences, design, and also domains. So what are the domains in which we concentrate on? We focus on automotive engineering. I am associated with the automotive engineering program. We also have programs on biomedical design and robotics. We have 7 faculty, a good number of adjunct faculty from the industry and research organization, and in my department. And coming to my research lab, so over the years I have established what is called as the automotive controls lab at IIT. So I focus on heavy road vehicles like trucks and buses from the days of masters and PhD. I have been continuing on that work at IIT Madras. I'll also motivate why it is important for India as I go strong. In my group, we focus on 2 things: safety and electrification, which are very important not only globally but also in India, and product and solution, in collaboration with the industry. And as we know, when we develop these automotive safety systems, active safety systems in general, and going into the realm of vehicle dynamics and control, 3 attributes become very important, right? So that of sensing, control, and actuation. So sort of like these are the 3 pillars on which any control system built upon. So we focus on all these 3 verticals to speak about. So in automotive controls, there active safety, like wherein we look at anti-lock brake systems, electronic stability control, and brake prognostics. So to ensure that we avoid accidents before they happen, and when the attention the leading cause of accidents. We also look at collision avoidance and under traffic conditions that are found in India and other nations. And in the domain of electronic, we focus on the optimal design of electrified powertrains, and also developing advanced braking strategies and also cooperative braking with both friction braking and regenerative braking that are available in electric. So let me go to the technical part of this talk. So as all of us are aware, heavy vehicles are used to carry freight and passengers, right? So let me start off with a few relevant statistics from India. So yeah, we can see that road transport accounts for the bulk of freight transport in India. Right, in India, like in the year 2030, and statistics cost is also a significant percentage of the final price of the goods. So we can see that around 18% of the final price of products are logistics. Okay, so economic perspective, logistics, freight movement becomes important. So we need safe logistics, we need efficient logistics, like efficient freight transport to try and bring down the cost associated with the same. And it also has environmental impact since nearly 7% CO2 emissions comes from the logistics, and it also has a safety impact because nearly 20% of road accidents involve a truck. So in India, right? So it becomes all the more important to look at safety and e-mobility, this class of vehicles. And coming to passenger transport, the second attribute with respect to heavy road vehicles. If you look at the model split of passenger transport in India in terms of passenger kilometers, we can observe the bulk of the transport happening on the road. That dominates. Although we have a very strong rail network and also a ever-developing air traffic or a rail system, most of the passenger transport still roads, right? And in the year 2019, it has been reported that there have been 2 million buses in India, and around 85% of passenger transport in terms of passenger kilometers happen by buses. And this segment has both private and government regulated players, who operate buses between cities, and hence their efficient operation and also the safe operation becomes extremely important. Because one of the most unfortunate that happened, and we heard in the news periodically, is that many of the buses that transport passengers on highways to accidents, and there is a lot of human cost associated with that. That's something we are working towards addressing. So in fact that brings to accidents. So safety is of paramount importance, giving the ever improving roadway design, and so vehicle design, right? So India, unfortunately, we have nearly 150,000 road accident fatalities every year. That's a very high number. We can see a relative comparison from a WHO report, and see other countries, including South Africa, data for this report. But that India, unfortunately, has a very high road accident fatality count. And this is something which the government is also proactively working towards reducing. So we'll see some of the measures that have been adopted by the government of India in this regard, particularly with respect to heavy vehicle segment. And why is the heavy road vehicle segment important in this regard? We can that typically heavy road vehicles, like constitute around 5% of registered vehicles on Indian roads. But they contribute around 1/3 of road fatalities. So that's a very high number, right? One reason is because, as we have already realized, a lot of passenger transport happens via buses on highways, and any accident involving such buses is going to be very detrimental, and it's going to be very costly in terms of human lives. So we want to work towards reducing not only the absolute number of fatalities due to road accidents, but also the accidents that happen due to heavy road vehicles, appear to be very disproportionate with respect to the number of such vehicles flying on the roads. And the leading cause of accidents is due to driver inattention. Right? Human errors play most important role as far as concerned. So we want to also develop tools, that can help drivers, be on highways during night under poor weather conditions and so on. Right? Because most of the passenger transport that happens between cities during the night, right? So that's when the risk of accidents also become higher, right? So due to driver fatigue or poor visibility or a combination of the factors, right? So we want to address that. So the government of India has been proactive, in taking steps. In fact, anti-lock brake systems have been mandated for the class of vehicles from 2015, right? And autonomous emergency braking be mandated. Hopefully, these active safety systems, would potentially bring down the number of accidents and fatalities. So there have been various active safety norms also through the Automotive Index 145. But the government of India is also taking proactive steps in ensuring that active safety systems are installed and used efficiently on road. That's something very positive. But there are challenges. Yeah. So because one has ABS and technology like collision warning, collision avoidance, autonomous emergency braking are already available on production vehicles worldwide. Then what are the specific challenges that we are encountering and we want to address? So I want to discuss some technical challenges from an engineer's perspective, so that I can motivate some of the work that we are doing in my lab. So if you look at this picture, we can see that we have different types of vehicles, occupying the same both space in India, right? So if I am looking at the roadway in front of me, right? So I'm going to have what is called as heterogeneous traffic, right? Maybe I lost connection for a few seconds there. If I look at the traffic in front of me, I'm going to have five classes of vehicles, that constitute what is called as heterogeneous traffic. So we can have two-wheelers, we can have buses, minibuses, right? We can have cars, right? We can have even three-wheelers and minivans occupying the same road space. And the operating and dynamic characteristics of these classes of vehicles are going to be different. So the question or the challenge that arises is that if we are developing active systems for such traffic, should we not take into account the differing dynamic characteristics so that we build an effective system. Right? So, and as we discussed, we need sensing, actuation, and control, right? So even if we develop collision avoidance systems or autonomous emergency braking, we need effective sensing mechanisms that can detect and classify various types of vehicles that we can find on roads. And another important practical challenge today, like on Indian roadways, is overloading, right? Actual data that have been collected and reported in these references report that, freight carrying vehicles were overloaded up to 120% of design capacity. And also up to 40% overload on an average. That's significant, right? So, because as we are aware, most of the systems in an automobile are designed for the gross vehicle, right? So now the question becomes, if we have this overloading, the question is, how will these active safety systems respond, right? So that becomes important research question for us to answer, right? And another practical challenge is cost, right? So as we already discussed, logistics accounts for 18% of the final price of goods, and you can see that varies the cost per ton kilometer, for freight is largest for road transport. Okay, so any technology, any solution that we develop, should also be cost effective in terms of both initial and operational costs for it to be successful. So that's a very important practical consideration which we should keep in mind, when we are trying to develop solutions, in this domain. So there are a few research challenges that motivate these research opportunities. So what can be related research that one could do? So one could essentially look at developing advanced driver assistance, like collision warning, collision avoidance, with different types of vehicles in fact, right? So that's an interesting problem. And we also need to develop control systems that are robust and adapt to varying operating conditions. So why does it important? Because as we realize, overloading is rampant. So if the mass of the vehicle changes, right? So the question becomes, is our system robust enough to overcome those uncertainties and still perform well, right? So that's where we have to run robust systems to function effectively. And another important requirement is that we need to have cost-effective solutions, right? Because for the systems to be implemented and used on roads, we need systems or solutions that will use the least amount of data, decipher the best amount of information from them, and then take action. So that becomes very important, right? So, and given the challenges we have seen in terms of detecting tracking vehicles, the question is, how do we develop sensing technology, right? Which use a combination of cameras, LiDAR, and radar, for traffic system or scenarios that we encounter in what I call as fixed traffic, right? That we see on Indian. And ultimately, for all these active systems to be successful, we need driver acceptance. So, in other words, these systems should not be designed, or it should be designed in such a way that there is a very systematic transfer of control from the human being to the active system rather than, right? Otherwise, the driver acceptance is going to be. So that's also an important area of research, which is also connected to the problems that I stated about. Right? So these are interesting challenges in the domain of safety. Okay. Now I'm going to the second part of my talk. So having talked about safety, seeing why safety is very critical as far as heavy road vehicles are concerned in India. So let's look at e-mobility. Okay? Once again, I will motivate some statistics, then we will see. So the transport sector per se. So all of us know that like transport sector is the big consumer of energy. It is significant source of emission, right? And if you look at trucks and buses, they account for significant greenhouse gas emissions, right? So these are well known. I just wanted numbers to things that we already know, right? So it becomes very important for us to address these issues so that like we have very efficient consumption of energy in transportation, in road transportation in particular, while ensuring that we are also reducing emissions. Right? So that becomes great. So why does it become important in the Indian context? Once again, we can start from this figure. So, yeah, that the CO2 emissions share transportation is increasing over in Asia, right? Economic development happening in India and China. This is right? So that also places a lot of emphasis on finding technologies that can resolve this. Right? So it becomes very important for us to assess this issue and try to reduce CO2 emissions. Right? Yeah. And emissions in India, unfortunately, is the world's third largest emitter of gases after China and the US. And observe that the contribution of transportation sector is also like increasing with time, right? So as far as CO2 emissions are concerned, and if you look at road transport, like that transport is a significant emitter of CO2 emissions, right? So all these point to an urgent need, like of developing alternative technologies that can provide us with green and sustainable mobility in India. Right? And also in India, we depend a lot on importing fossil fuels. So there is an economic angle to this, right? Because fuel prices correspondingly are set by external factors and they are quite expensive, right? They are in operation. If you look at freight operators and passenger bus. So what have been done by the government of India for the past several last decade, the government of India launched the National Electric Mobility Mission Plan, which aims at improving the production and sales of hybrid vehicles. So today we are seeing an increasing shift towards electric vehicles, particularly in the urban, particularly on urban. And more so in the domain of two-wheelers. Because two-wheelers dominate the vehicle distribution or the number of vehicles in Indian roads. So there has been a tremendous shift in manufacturing and selling electric two-wheelers and also electric buses that can operate in cities. So been a significant thrust, and that has also been catalyzed by this so-called adoption and manufacturing of hybrid electric vehicles. So wherein, the government of India is providing subsidies to both manufacturers and consumers to produce and purchase and address the emission norms. In India, we directly shifted from what is called the Bharat Stage 4 to the Bharat 6 norms. So the Bharat emission are motivating Euro norm for emissions, transportation, and we went directly 4 to 6 given the fact of emission of data. And the government of India also shared and connected mobility in the future going forward, and great emphasis on shared mobility and public transport. Right? So those are some areas. And in fact, if you look at the current focus, it's on urban. So the immediate focus of the government is on getting more electric vehicles within cities, be it electric or electric cars or the electric buses. So, and slowly one hopes that this also shifts to highways as far as freight transport and long distance bus transport is concerned. So, what are the corresponding challenges and research opportunities that one identify? So, I'm only talking about the engineering challenges, right? So, from an energy perspective, a lot of work is happening in developing alternative energy sources for EMobility, and with the increased penetration of electric vehicles within cities, there is a lot of work also going on technologies with respect to battery swapping and public charging infrastructure and so on. From a vehicle perspective, obviously vehicle design itself, an interesting challenge, right? So we essentially shift to electric vehicles, right? So as we know, electric vehicles does not involve just replacing the conventional IC engine powered electric pump, right? But one also needs to look at overall vehicle design. And the opportunity of class of vehicles also is paramount. And handling the right response, braking response of these class of vehicles becomes important, which also leads to augment safety and comfort. And from a traffic operations perspective, there is quite a bit of info about shared mobility, how to actually have efficient routing, particularly under peak traffic, where the peak of traffic jams, right, and open roads. So how to optimize our time and operate electric vehicles on roads. That's something is also being actively pursued. Okay. So I'm just going to end the talk with some slide on how we can move forward. I thought I will use this opportunity to interact with you to share some ideas about related research on safety and e-mobility, particularly in heavy vehicles. Now, let's say we want to get started with some discussions on research collaboration. What do we do? So we follow the structure. So first, there are faculty level interactions. So it's really we start off with conversations between like-minded faculty who essentially talk to each other, and then essentially come to an agreement to work together and collaborate with each other. This typically followed by the exchange of students, particularly postgraduate students at the master's, the PhD level, who essentially collaborate together, work on joint problems and publish together. This is then followed by joint supervision of the PhD candidates. That is masters and PhD students who are admitted at partnering institutes, right, are jointly supervised by an IITM faculty and faculty as a partner. And ultimately, if these things are successful, we discussed with the university per se on offering joint doctorate of degrees. So I think these are the various levels of interactions that are possible and are already going. So I thought I will share this information with this group. So I think that's all I have to share with you today. I will be happy to discuss with you and listen to your questions and answer them. Thank you.
Great, thanks, Shankar. That was a very, very interesting talk, and I was blown away by 150,000 fertilities per year in India. But over to anyone who has any questions, perhaps Dean.
Thanks for throwing me under the bus there, Frank. I can't think of any specific questions right off the bat, unfortunately. So if anyone else wants to ask something specific, and I'll see if I can jump in afterwards.
Apologies, Dean. I didn't really mean to put you under the spot.
No problem.
I just think with your research topic, and I've looked at Shankar's papers on connected and automated vehicles, and he didn't give much detail on that, which is a real shame. I thought you might be a good candidate to have some questions. So that was the reason why you were picked on. It wasn't any other bad bad intention on my part.
Well, Frank, I'd be glad to have discussions. People can email. So in this discussion, I thought I would broad overview. I just find next.
Shankar, it seems quite exciting with your proposal for some research collaboration. Do you have any perhaps funding opportunities that we might be able to look at between this and IIT?
Yes, I think the Department of Science and Technology, which is the scientific organization which funds research, typically releases calls for joint proposals with various nations. So I have in the past applied for joint funding as part of the project with US university. So we can also look at collaboration. The first step would be to essentially establish a working relationship between corresponding personnel, right, from either universities, and look at like mutual research interests and identify problems, like that one could, and then like certainly pursue funding opportunities that will allow for exchange of personnel and also perhaps fund actual research, not aid.
that sounds really quite positive. Michael, I see you've got your hand up. You want to go ahead and ask your question?
Thank you, Frank. I was just thank you very much for your talk. I'd just like to get your insights into the challenges of making autonomous vehicles viable, specifically from the sensor array in terms of integrating cameras, radar, and LiDAR. There's been issues in terms of the robustness of cameras at being able to detect objects and possibly being the source of accidents. Do you have any idea on how we can overcome this problem?
I think that's a very relevant question. So if I can go to the corresponding slide where we alluded to it. So as we discussed, like, at least from my perspective, there are three broad pillars, right? Sensors, control algorithm, and the actuators, right? So in fact, it's very important if you want to bring in more vehicle autonomy, right? And we may not have one specific technology that may work very well under operating conditions. In my lab, we have developed a cost-effective solid-state LiDAR sensing system towards detecting and tracking different classes of things. Now, in relation to your question, we are working with an expert in image processing and one expert on radar to see whether we can fuse the data from all the three sensors, right, and use them effectively for vehicle state estimation and automotive control. So hopefully, maybe a few years down the line, I would be able to share results from this exercise that we are carrying out respect to integrating various things, right? Yeah. So of course, each sensor has its own pros and cons, right? And so we are trying to see what is the best that we can get out of this.
Thanks, Shankar. Are there any further questions? Please fire away. Philip, go ahead.
Thanks, Frank. Shankar, I was surprised at the amount of overloading on the trucks in India. And I was wondering, I mean, apart from a safety concern, it would also be doing immense damage to the road surfaces, I imagine. So are there initiatives underway to try and limit that overloading?
Absolutely. I think spot on, Philip. In fact, the research team that collected this data, are payment engineers. Because the overloading, of course, naturally damage the roadway. And one of the significant operational costs for the transportation, particularly the highway network, be damaged to us, right? So there are issues where
Okay, I'm gonna jump in here. Apologies. It seems like we've lost Shankar with the connection. Fortunately, though, we managed to get through his presentation.
Frank, am I audible now? Yeah.
Good stuff. Go ahead, Shankar.
Oh, okay. I'm sorry. I think there was some disruption in between. So just to continue from where I left off, Philip, the data that is presented here are from payment and how they are working in my lab simulations to quantify what is the extent of damage, like that can happen to payments, so that we can also approach policymakers. In this regard. In fact, the government of India has increased the axle load limits, like to counteract this rampant overloading. But payment engineering would be better able to answer, like what initiatives would be taken to strengthen the roadway, right? So, yeah, we can increase the legal limits of axle load, but still they are going to, sort of stress out the payment, right? So, yeah, you are absolutely correct. I think my colleagues in payment engineering are working on this.
Great, thanks, Shankar. See, Dean, you've finally had time to think of a question, so please go ahead and thanks.
Yeah, sure. Thanks, Frank. Thanks for the presentation, Shankar. So yeah, with my research, I'm kind of focusing on the bit on the sensors and more on the control side, looking at applications of end-to-end machine learning models for autonomous vehicle control. And I was just wondering, in terms of sensors, so first of all, I'd like to hear a little bit more about your in-house cost-effective LiDAR sensor, and in terms of it being cost-effective and possibly about its size and weight, how would you compare that to a similar camera system that would be used in a similar kind of place? Are you getting to similar kinds of sizes, weights, and costs, or is it still a bit more? And then, do you see any value in using cameras and LiDAR side by side, seeing as they're operating essentially on the same spectrum, and they're giving you essentially the same information, whereas with, say, a radar and one of these, you could argue that you're looking at a different spectrum with different penetrations and you're actually getting different data?
So let me answer the first part of the question. So are trying out, a solid state data, right? So which are relatively inexpensive when compared to the scanning. So we have developed a sensing system where we have procured an 8-segment LiDAR with a 20-degree field of view for a very first application, like of tracking vehicles in front or collision avoidance applications. So now, if you look at the cost of this sensor, it is pretty economical. In terms of the actual numbers, I don't have the comparison with cameras right now. But as I mentioned, that integration we are going to try out. Like that ongoing started with a colleague on who's an expert on edge processing, right? Where we are going to integrate cameras and the solid state LiDARs, which are almost comparable in size, right? And use data from both, like in particularly access safety applications, right? So it could be extended to greater autonomous functionalities also, right? So in terms of size, once again, I don't have a direct numerical comparison, but the sensing system that we have assembled is pretty compact. Can be mounted on board. So that I don't what I say. I think it's comparable to camera-based system. Ultimately, we want to have an integrated sensing system, and preliminary discussions with my colleague pointing to the fact that we'll also be using techniques from machine learning to figure as to how to process this data, right? Before we transmit the data to our controller.
Thanks, Shankar. I think if there are no more questions, then I think it's appropriate to thank our speaker again. Thanks, Prof. Shankaram. And yeah, we look forward to the next presentation. So yeah, maybe perhaps a round of applause and a double thumbs up. Thanks, Shankar.
Thank you. Thank you, Frank. Thank you all. Thank you. Please email me. We can have some conversations about mutual respect and certainly and take this forward. So, yeah. Thank you. Thank you for organizing this.
Thank you.
I'll take